So integrated to 4.2.1, now we're going to talk about the other two trig ratios that we're going to be dealing with this year. So we've already talked about tangent. Now we're going to be talking about both sine and cosine. The key to this is being able to identify the side lengths with regards to the angle itself. So if we take a look at the picture over here on the right-hand side, we've already done a little bit of practice with identifying the opposite and the adjacent. Haven't really brought the hypotenuse into this yet. However, I think out of all of them, that's probably the easiest one for most people to identify because the hypotenuse is always going to be opposite the 90-degree angle. So if we can find the box in the triangle, then we can always find the hypotenuse. So if we go through and do a little bit of color coding here, we've already talked about how the angles and the sides kind of pair up together. So there's our hypotenuse, always opposite the 90-degree angle. Starting from the angle theta, or whatever the angle is that we're using, we're going to go opposite that, and that is going to give us our opposite side, which in this case is identified as y. It doesn't have to be, it just can be. Then the last side, which by default it's the last one typically that you would identify, is the adjacent side. And it is the side that is right next to the angle in question, but not the hypotenuse. So that's why I recommend typically identifying the opposite and the hypotenuse before adjacent. So you don't want to confuse the adjacent side with the hypotenuse itself. Okay, now that we've done that, we can go over and take a look at all three of these trig ratios. So there are more. We are only going to be dealing with sine, cosine, and tangent this year. But again, the key is being able to identify the sides that we have based off of the angle. So starting from angle theta, so we don't want to start from the 90-degree angle unless we're identifying the hypotenuse. It's the only time we're going to start from the 90. So start from the box in the corner, go straight across. That's going to give us our hypotenuse. Now, all of the other ones, we're going to start from the marked angle or the identified angle theta. We're going to go straight across. We're going to identify this as the opposite side. Then the only side that's left over is going to be the adjacent. You'll notice that it is also right next to the angle, not the hypotenuse. Okay, now we have our three trig ratios. We've already spent a decent amount of time with tangent. We know that tangent really is the slope ratio, so you can think about it as rise over run. Then we have the next ratio, which is going to be sine. Sine is the comparison between the opposite side and the hypotenuse. And then the last one is going to be cosine, which is the adjacent compared to the hypotenuse. So what you will hear, is a pretty popular little mnemonic device, is SOHCAHTOA. So we know that sine is opposite O over hypotenuse H. We know that cosine is adjacent A over hypotenuse H. And we know tangent is opposite O over adjacent A. So what you will hear quite a bit is SOHCAHTOA. It's just a mnemonic device that we use. Okay, moving on to some examples. We want to solve for sides A and C. Okay, so we're going to identify our sides based off of the angles that are given to us. So we know starting from the box and going straight across, C is going to be the hypotenuse, or H. Starting from the acute angle 39, we'll go opposite. So it looks like the 6 is the opposite side. And then the only side left for identification is going to be right next to the angle, and that's going to be our adjacent side. We only want to we only want to group three things together, an angle and two of the sides. want to make sure that we don't mix too many unknowns together. So I think what I'm going to do is I'm going to solve for the letter A first. Well, if I'm solving for A, then C cannot be involved simultaneously. So I want to use the 39-degree angle. So here's what I'm thinking. If I want to solve for A, I'm going to use the 39-degree angle. I am going to use the letter A. It's got to have it, so that's what I'm looking for. And I'm going to use the 6. So just identifying those things, it looks like I am using the adjacent and the opposite. Well, opposite and adjacent is tangent. So I'm going to do tangent of the angle, 39, is equal to opposite, which in this case is 6, over adjacent, which is A. I'm going to go ahead and give this a denominator of 1 and cross multiply. So this is going to be A times tangent of 39 is equal to 1 times 6, which is 6. Remember, tangent of 39 is just a number, so we're going to divide by tangent of 39. Since it's currently multiplying to A. Now, tangent of 39 cancels with tangent of 39. So the exact answer is going to be 6 divided by tangent of 39. From here, grab our calculator and type it in. And we end up with 7.4093. Do a quick look on that. Make sure that that is an acceptable value for A, which it is. We know that the other angle inside the triangle is going to be 51 degrees using triangle sum. And the 51 is opposite A, so A should be bigger than the 6, which is opposite 39. Okay, so there's A. Now we need to be able to solve for C. So to solve for C, I don't want to use A if I can avoid it. So for C, I'm still going to use the angle 39. I need to have C in the problem, and then let's use the other given value, which is 6. So that is going to be the acute angle, the hypotenuse, and the opposite side. Well, that is going to be sine. So we're going to do sine of the angle is equal to opposite, which is 6, over hypotenuse, which is C. Notice the setup's the same. We're just using a different trig ratio. So cross multiply. So 6 times sine 39 is equal to 6. We're going to divide by sine 39. So the exact answer, so those signs are going to cancel, is going to be C is equal to 6 divided by sine 39. I'm going to do a quick check on this. Now my expectation, because C is the hypotenuse, is that it is going to be the longest side. So 6 was one of the sides. The other side was 7.4093. So I expect this to be bigger than both of those, which it is. So if I plug this into my calculator, I'm going to get 9.534. So that is C. All right, let's move on to B. We want to go through and do the same thing. Now, 2 is just like 1. So why don't you take this opportunity and see if we can solve for the sides that we're looking for. And we are looking for sides. So we want to find that blue X, and we want to find the orange Y. So see if you can set up these ratios, use the appropriate trig, be careful that you identify the sides, and then come back and check. Okay, so check your answers against mine on number 2. It looks like 51 degrees is going to be the larger of the two angles, the two acute angles. So I believe X should be bigger than Y, which it is. Not too much of a difference though, because the other angle is going to be 39 degrees if I use triangle sum. Okay, question number 3. Question number 3, we want to find the perimeter. Well, we need to remember that perimeter means to go all the way around an object. So I think we need to find the two missing side lengths. Well, I'm going to identify them based off of the angles that they go with. So if this is angle G, that is 51, then across from it is going to be lowercase g. Okay. With the box in the corner being angle H, then across from it is going to be lowercase h. So we need to find G and H in the picture. Now, you've got multiple angles that you could choose from. You could use the 51 degrees or you could use the 39. It doesn't matter which one you use. It is going to change the setup of your question, but it will not change the answers. I think I'm going to go ahead and use the 51. Not that it matters. Again, you get the same answer. So I know that across from the H, this is going to be the hypotenuse. Okay, now I chose the 51. So across from the 51, this is going to be the opposite side, which means the 57 is going to be the adjacent. Again, you could have used the 39. However, if you use the 39, you'll notice that the opposite and the adjacent change names. So they swap places because you're using a different angle. So why don't you take this opportunity and solve for G and H in the picture, just like on the previous two questions, and then come back and we will do perimeter. So here are my exact and approximate solutions for G and H. And we know H is the hypotenuse, it better be the longest side, which it is. Then the 51 angle is bigger than the 39, so the G side, it better be bigger than 57, which it is. The last thing we need to do for perimeter is to add everything up. So just around. So we're going to take the 57, then the value we got for lowercase g, and the value we got for lowercase p. This is going to be an approximation because we're using approximate answers to get it. So if we add those together, it looks like we get 217.962 units. So there is our answer for this one. Now on the next slide, we have some more practice problems. So my recommendation to you is to attempt question number 4, come back and check your answer. So pause the video, then pause it again, do 5, come back and check your answer. And then lastly, do the same thing with 6. Okay, so here's my work for question number 4. I did end up using tangent for this one, and I'm always doing a quick check. The 34-degree acute angle is going to be smaller than the other one, which is 56, using triangle sum, which means the side length of 39 is going to be smaller than the side length of x. Is that true? Yes, that's what I got. Okay, pause, do number 5, come back and check. Okay, so here's the worked out answer to question number 5. Quick check, does the size of x make sense? Yeah, it does. Okay, why don't you try number 6? Okay, and then the final question for these notes, I ended up having to use sine because of the ratio that popped up in the triangle with opposite and hypotenuse. Do a quick check on this. The 38 is the hypotenuse, definitely needs to be the longest side. Is x smaller than that? Yes, it is. And actually 66 is a pretty big angle. The other angle would have been 24, so I think it's reasonable to think that this x side length is going to be 34.714.